Well, it is 2 o'clock and I want to give these gentlemen the most time possible. So I'm going to quickly just introduce Roger Sutherland and then Ranger Kidwell Ross, and they're going to be talking about sweeping, and I'm excited about this. So I'm going to let them introduce themselves in a little more detail. But thank you for attending this Stormwater Awareness Week workshop, and you can put your comments and questions in the chat, and we'll be fielding those to our presenters towards the end. All right, gentlemen, Ranger, Roger, it's all yours.
Well, all right. I'm the Ranger part of this show, and my name's Ranger Kidwell Ross. As you heard, I'm the principal and the editor of worldsweeper.com, which tagline is Earth's largest power sweeping resource, and we certainly are. I'm also the director of the World Sweeping Association, and I'm so fortunate today to be presenting this conference with the capable assistance of Roger Sutherland. He's a noted sweeper researcher, principal with Oregon-based Cascade Water Resources, LLC. He's a senior water resources engineer with over 50 years of professional engineering experience in water quality planning, BMP design, and modeling. He's a recognized international expert in urban stormwater load modeling and the use of both street sweeping and catch basin cleaning practices as a way to remove pollutants from urban runoff. In addition, he's the principal author of a state-of-the-art urban stormwater quality modeling package called SIM-PTM, which has been used on numerous projects and was recognized by the United States Geological Survey as the best stormwater quality water modeling package in the country. He has authored well over 50 publications, primarily on stormwater quality modeling and the pollutant reduction benefits associated with cleaning practices like street sweeping. Many of those can be found at my website, worldsweeper.com, and a selection of the best and the ones with the most impact are also co-listed at researchgate.com. He has either presented or taught at conferences and short courses on the topics of urban hydrology, hydraulics, and water quality well over 100 times since 1975. We say all of these things so that you'll be really listening to the knowledge that he has to impart. He's lectured 17 times from as a faculty member for the Designing Best Management Practices for Stormwater Quality Improvement short course that was sponsored by the University of Wisconsin. Together, we have conducted several stormwater information seminars in California that were for stormwater professionals. And our webinar today for National Stormwater Awareness Week, we're pleased to be invited for this, is called Street Sweeping, Clearly America's First Line of Defense for Stormwater Pollution Runoff Abatement. And at this point, I'll let Roger take it away. He's going to be the person responsible for the first portion of our presentation. And I also want to thank everybody for their interest in water quality and making water quality much better.
All right. Well, thank you very much, Ranger, for that very nice introduction. So, street sweeping in America dates back to 1849, for those that aren't aware of that. A gentleman by the name of C.S. Bishop built the first horse-drawn street sweeper. And then it was 1913 that John M. Murphy built the first motor-drawn street sweeper. But the first slide that we're going to be looking at, there's a photograph of a horse-drawn street sweeper. I believe that's the early 1900s, and that's a street in Chicago, Illinois. And it clearly, these machines were mostly invented to sweep up horse poop and similar waste products with an emphasis on cosmetic results and not water quality. But darting back to the early 1980s, the US EPA decided to invest about $30 million, which was a lot of money back then, in the examination of the various best management practices that we have been talking about for a number of years at this point in time. That's how dated I am. And they decided they wanted to study the effectiveness of street sweepers in reducing event mean concentration for 5 pollutants, which are listed here. They selected 10 sites located in 4 states, which are also listed. And you know what? It was the unexplainable negative results from 2 sites in North Carolina and 1 in Wisconsin that resulted in the conclusion, and I quote, "Street sweeping is generally ineffective as a technique for improving the quality of urban runoff." They arrived at this conclusion despite the fact that the data clearly showed EMC decreases in 34 of 50 site pollutant investigations. In fact, the word statistically indeterminate has been hampering the street sweeping industry in terms of trying to quantify the BMP value of that technique for many, many years. Well, let's talk about the good news. The good news is that today's mechanical broom sweepers, unlike the ones that were tested in 1981 to 82, they have doubled or even tripled the pollutant pickup efficiency of those old style machines. In fact, in the year 2008, I was contacted by Elgin Sweeper Corporation, and they wanted me to conduct some third-party, non-biased tests on a number of machines that they were developing and were about to release in the marketplace. And you can see there pictured on the right is an Elgin Eagle broom sweeper taken at that point in time. And we tested it using a set of procedures that, by the way, apparently have become close to standard that are being used as we speak in other locations. And I recommend that you contact me if you want more information and you want to do this. This procedures involve the development of a simulant that simulates the physical and physical characteristics of street dirt, so you can put it out there a known amount and then you can run a test. We concluded in those tests that the efficiency of this machine in the 250 micron or less was as much as 86%, which was really a shocking conclusion for me, not knowing what the results had been. I've tested others in the past and mechanicals just weren't performing that well. However, one of the things we did discover is the use of water, which is quite a common practice for the suppression of dust. It reduces fine pickup performance by 20%, and that goes down. So the use of water in your sweeping activity might not be the best thing to do, but if fugitive dust is a concern, you can buy a street sweeper that filters that right out. So here, let's talk a little about even better news. Modern air sweepers have vastly increased our ability to pick up this fine material, especially the really fine stuff, less than 63 microns is the smallest range we look at, and to remove the pollutants that are associated with that material and all the other material that they pick up. In fact, my test of the Elgin Crosswind, which is pictured in this slide here, at the same time, determined that the under 250 micron fraction, which I focus on because it's by far the most bioavailable and mobile fraction of these debris sizes, we had removals of 90 to 95% have been achieved. So if you really are interested in designing the best street sweeping program that can remove fine particle material, then you're going to want to look at a tandem operation. A tandem operation is a mechanical broom sweeper followed immediately by an air sweeper. And this will provide you the most effective pickup performance. Way back in 1994, I was commissioned by the city of Portland, Oregon to do a study and monitor the pickup performance. And we decided to do a monthly tandem sweeping operation. We used before and after street dirt sampling. Some of the people listening on this broadcast were involved in that collection, sure. And we compared that against the standard of a mechanical only operation, which we ran over a 6-month period. And we concluded that the tandem operation was able to pick up 74% of the material that we documented that was on the street, compared to just 40% or so for the standalone. So why I want to focus on this is because at that point in time, the light bulb goes on and I go, I get it. I know why the NERP had negative results, because they were aggressively sweeping with a boom sweeper, a mechanical sweeper of the time, which were really horrible. And all they really did was pick up the coarse material and left all of this fine material exposed to the next rainfall. And so the storms in which this occurred were high intensity storms like in North Carolina, and you'll get every once in a while in Wisconsin. So moving on, in 2009, the city of Seattle decided to do a street sweeping pilot. I was involved in the original design of the study. I also was hired to train personnel. Herrera and Associates, Herrera consultants were involved in Seattle. I trained those folks how to go up and pick up street dirt and all that sort of thing. I wasn't involved in the actual data collection nor the analysis, but what they concluded was a stormwater pollutant approach. And that approach involved street sweeping and catch basin cleaning. Seattle had gotten away from street sweeping, like so many communities throughout America after the NERP results. They really didn't have a significant street sweeping program at that point. But they concluded that approach could significantly increase the mass amount of pollutant removed from stormwater. In fact, in 2011, they determined that over a 2-year period, they increased the amount of pollutants being removed by stormwater by over 300%. Further studies suggested they needed more money for street sweeping. They doubled the budget. And as far as I know, that's even increased even further. So it's important that we talk about this next slide, at least for a little bit of time. I'm going to make a bold statement here. Sweeping reduces pollutant concentrations, period, end of story. The reason I know this is because, as Ranger mentioned, I designed a computer model dating back to the University of Maryland in the early 1973. And I worked on this model relentlessly, one project or another. It was a model that could model this behavior, accumulation and wash off of material, and the interaction of the street sweeper. And what I found over and over again, we calibrated mostly to street dirt collection, is that we're showing significant reductions in concentration and load at the point in which the water goes into the catch basin. I never found it in the literature, and it was frustrating. I took a lot of criticism for what I was publishing as not being realistic. But finally, in the year 2009, 2010, the city of San Diego, as part of their targeted aggressive street sweeping pilot, determined that was exactly the case. They sampled 3 different storms that occurred. They had an unswept area. They had an area that was swept by a mechanical sweeper and one by a vacuum. That table shows you the results, and they're very significant. TSS was reduced by 74% on average by mechanical sweeping, 85% by vacuum, but reduction in metals were also very impressive and significant. 60% from mechanical and up to 83% for vacuum. So the reason I mentioned this, and Ranger's going to talk a little bit about a project we're involved in whose focus is actually microplastics. But one of the things we're looking at is whether street sweeping can be an effective way to control those. And we have an agency that's involved, the Southern California Coastal Water Resource Project Authority, and they're going to do a study. In fact, it might even be underway, I'm not sure. And they state in their scope of work that, and I want to quote this because I think they need to understand that's not accurate. No study to date has shown the effect of street sweeping on downstream water quality outfalls, or any study definitively quantified differences in runoff concentrations between swept and unswept streets. Well, I just showed you that's not the case. But I'm really excited about their work on this because it needs more attention. They're going to use simulated rainfall, and they're going to focus on roadways in California that are heavily trafficked. And I think if they were to collect the samples of the water going into the catch basin right off of the curb or down a slope into a whatever catchment, that's the way to get this conclusion, because that's what happened in San Diego. This is the first time this was ever done, to my knowledge, dating all the way back to Champaign-Urbana in the original NERP. So enough said, let's move on. One of the things I really wanted to emphasize was the most important work that has happened on this topic, and to my knowledge, started in the year 2007, ended in 2019. The University of Florida, involved with the help of 12 to 14 Florida MS4s and in association with the California Stormwater Association, they found that street sweeping was by far the best BMP, up to almost 7 times more cost effective than any BMP that they examined for looking at nitrogen and phosphorus recovery. So their work, working with all of these MS4s, was to sample waste either from street sweepers, catch basin cleaning, end of pipe, structural practices, and there was a range of them that they documented, and then calculated the cost of capturing a pound of nitrogen or phosphorus for each one of these recovery methods. And they concluded that sweeping was the lowest cost per pound by far, and catch basin cleaning was always second in all instances. In fact, the graphic shows that nitrogen, we're talking 189 pounds per removal of nitrogen versus 1,162. That's like 6.5 times more expensive. And when you look at the mean of the best management practices that we're talking about, end of pipe controls, like separators, things you can put in there, not filters. But anyway, that's 2173. That's 11 times more expensive. But here's the real important thing, because most people in the country are more interested in phosphorus than nitrogen. But look at street sweeping, 294 per pound. We have information that suggests that Minnesota is actually finding this to be less than 294 using modern air sweeping machines. Look at the second one, 1894. That's still 6.5 times more expensive. But the third one is like 41 times more expensive. That's the mean, $12,000 a pound to remove a pound of phosphorus. So clearly, street sweeping is the first line of defense. And now this is proven by the work of this. And so the key here is that the collection of material, particulate material, matters. The more particulate material that you collect, the more removal of pollutants you'll get. But most importantly, this is the most important thing. The study results are statistically defensible at a 95% confidence level when combining all 14 MS4s for particulate material, TN, and PN. We've never had a conclusion like that before. Finally, someone did the work. They spent the millions and millions of dollars and took the time to get enough data to make that conclusion. And so that's why we're so excited about this result. Now, I wanted to talk a little bit about another thing we learned from John Sansaloni, who ran the study there, is that there are a number of crediting programs throughout the country that credit the collection of street sweeping waste, which was kind of a surprise to Ranger and I when we found this out. I've done a little research. I've listed these programs. Notice Florida's there, all MS4 communities with street sweeping waste data. That's really important. And so what I learned in doing a little bit of research is that there's a really wide range of methods that they're using to collect, to determine the crediting, how much the credits are worth. And I've listed these methods here on the slide, but I think the one that's most important is the last one, performance-based compliance. I also learned that most of them look at TP, phosphorus, nitrogen, or even TKN, total keldal nitrogen. But I think it's really important that we start to standardize these programs. And the most scientific approach, the best approach, is the approach that the Florida took, where it says, you want to be in the program? Great. You're going to have to spend a little money. You're going to have to sample your waste using an established protocol. You're going to be able to determine how much of a credit you should get for the waste you're collecting, whether that's street sweeping waste, catch basin cleaning waste, whether that's waste coming out of a structural device. And I think it's really important that we do this. The last slide in this area that I'm going to talk about is I wanted to put up for everyone to view that there are some programs in California, since this is California's Stormwater Awareness Week. I don't know much about them. I've given you a little bit of details there, but I think the key here moving forward is for these programs and other programs that haven't been established yet, they need to be more standardized, and we need to get to a scientifically accurate and statistically defensible estimate of how effective they really are. I'm going to finish my presentation and talk to you about some things that are very dear to my heart that I've spent most of my career studying and learning about, more than anything else, learning about. And oh, sorry, before I get there, let's talk about what's going on in down in Southern California. As we speak right now, the city of Los Angeles, with Larry Walker and Associates leading the effort, is currently testing their street sweeper pickup performance using the procedures that I documented with the Elgin Street Sweeping Company back in 2008. The city has also applied for funding to support to identify and support enhancements to their program. They think they could significantly increase. I know they could significantly increase the amount of material they're picking up and the contaminants that they're removing from stormwater. And then there's the mention of the Southern California Coastal Water Resources Authority that I already discussed. And once again, my advice to them is collect the data in the beaker going into the catch basin. I know it's more difficult, but that's where you're going to find significant results. So the last slide is I'm going to talk to you about the various things that we can do or have done and will continue to do to look at how we can increase the program's ability to collect contaminated material more effectively. Obviously, the type of machine you're using is huge. There's cost impacts if you want to do a tandem. Some communities, especially in the Midwest, for example, they have a huge loading they're dealing with at the end of spring breakup, and mechanical sweepers make a lot of sense. Why do we have to have one type of sweeper for the entire fleet? Why don't we have a mixture? Because there's various times when we would use the difference. You know, looking at forward speed. At one time, I thought this was going to be extremely important. And what I found is, the manufacturer says 3 to 6 miles per hour. But the reality is, how many miles can you sweep in a shift versus going a little bit faster? So I tested in the city of Burbank with Glendale, California involved as well. 2012, I think it was, we tested some street sweepers using my protocol, and we found that if we increased it to 8 to 10 miles per hour, we only lost 10 to 15%. So when you factor in how many more streets and how much more material you're picking up, that seems to be much more sensible. The other thing, of course, is looking at your frequency. Frequency is usually determined by land use. The reality is it should be determined by traffic volume. And that, because that's the ones that accumulate the highest in terms of street dirt. Typical, we're talking daily, bi-weekly, or weekly, monthly. I have to tell you that bi-weekly sweeping of the downtown CBD for water quality protection is largely a waste of a lot of money. You don't need to sweep it that often. Now, the trash amendments that are happening in California might dictate that you need to, but generally speaking, in other communities, that's not necessarily the case. But of all these things I've listed, the last one is the most important. Ranger in his discussion is going to put an emphasis on this, as we all should. Mandatory vehicle removal during sweeping is the entire ballgame. You can magically increase the amount of material you're picking up by 30 to 60%, depending on parking density, by making sure the cars are not there when you're sweeping. And that vehicle removal creates a tremendous amount of challenges, but it's got to be mandatory. The city of Seattle started it voluntarily in their 2009, and they found out within 2 weeks this wasn't working. They made it mandatory. They issued tickets. I don't want to say this is the reason to do it, but believe me, the income from those tickets can largely offset a significant cost of the program. So what I want to do now is introduce to you Ranger Kidwell Ross, who spoke a little bit earlier, and then he's going to present the rest of the hour. He's a graduate level economist. He's the world's most published author on the topic of power street sweeping anywhere in the world, okay? In the early 1990s, he founded the U.S. industry's first web page dedicated to the power sweeping industry called American Sweeper. Today, he owns and operates as editor the largest resource on the planet for power sweeping, and that's worldsweeper.com. By the way, this webpage has been up and running for 29 years, and for 29 straight years, he's received one or most likely several more Apex Awards of Excellence. So it's an amazing resource, and as a stormwater professional, you should be aware of it and go there when you need some information. He's also the founder and the director of the World Sweeping Association, which has its membership includes all the major manufacturers in America today. And I believe it's well past 10 years of its existence. And of all of these things, he is the first person associated with the power sweeping industry to ever be inducted in the Pavement Hall of Fame. Something I really should strive for him, I think. Go take it away, Ranger.
Ranger, you need to unmute yourself.
Thanks, Roger. It's great to have such a warm welcome. I have one clarification to make, which is there have been 29 years straight of awards for publication excellence, but some of those came first for American Sweeper magazine, which was the first magazine ever for the power sweeping industry, and those have carried on, I'm proud to say, with the World Sweeper website. Let me start off by talking about the plus and minus aspects of street sweeping. Yes, there have always been here we go. You can see there are disadvantages that people cite about sweeping the streets. It's cost. Yes, they're costly, and they've gotten more costly as time has gone on. They're tough to maintain. People ask me that don't know anything, what do sweepers do? I say they break, but it's still worth it, and it's still the most cost-effective way when it comes to dealing with stormwater pollution runoff that there is. We know that conclusively now in both Florida studies and in Minnesota. People in the town are resistant to vehicle removal requirements. I'm going to show you some ways, given today's technology, that we can now mitigate that. And that's a very important part, because getting buy-in from your residents is very important. And sweepers, unfortunately, can't operate, or it doesn't make sense during heavy rain, and freezing weather is a mitigation too, since many do use water still for dust suppression. However, there is no real estate cost to street sweeping. There's nobody has to be dislocated. There's no infrastructure, which is very expensive to both buy and develop infrastructure to maintain. You don't have to check your catch basin filters and so forth. And now we know, as Roger talked with these different studies, and there are many of those on worldsweeper.com, sweeping is the most effective and costs the least. So there are some ways that you can enhance sweeping's value to your community. We know that it's the most cost-effective way to reduce stormwater pollutants that are running off, and that's huge right now and becoming more huge as we go along with water shortages. Roger's SimPTM is a computer-based modeling software that can accurately model the pollutant removal. So you don't have to do these expensive paired basin studies where you leave something unswept, do something swept, and see what the results are. He can model that for you using your rainfall data over many years and other factors as well. Then you can also optimize the value of sweeping by allocating your sweeping program resources. And one of the best ways to do this is to add the sweeping department and the stormwater departments together. That it takes the sharing, takes any kind of culture wars out of those two organizations. And a lot of times stormwater departments have a good budget, either through governmental grants, or a lot of times they have some kind of a fee attached to garbage pickup, and then allocate your resources so that you sweep as often as you should, and only after that move over to catch basins and those sort of things with filters. You need to determine, also very important, the correct mix of air and broom sweepers. I want to go back to the Florida study, and one of the criticisms that Roger and I both have of that study, and it's about the only criticism, is they didn't separate out broom and air sweeper data when they did those reports. So we're up to typically 6.5, 7 times more cost effective for sweeping, but that combined the broom and the air results, and they didn't segment those out as the results came in from the different MS4s. They could have done that easily. Nobody knew enough about sweeping to know that they should do that. So I talked to Dr. Sansaloni. He said it would be pretty expensive to go back and separate that data out, but it's very important that you realize the difference between these two types of sweeper technologies. There are really 3: mechanical broom, regenerative air, and vacuum. Broom sweepers, mechanical broom, they're just not as efficient at small micron pickup. They have just a broom action that's usually transverse of the entire sweeper. It scrubs the pavement, it puts the material up onto some kind of a conveyor belt, and it can scrub up the large amount of surface dirt on the street, expose the small micron particles, and then they're available till the next rainstorm or wind event. And they can sometimes create smaller particles out of the bigger particles. And we know that only about 10% of the material on an average city street is 250 microns or smaller. Now, our hair is about 73 microns. So let's think 3 times the width of your hair. Only about 10% of the material on the street is that small, but for reasons of physics, up to 60% of the pollutant load the EPA is trying to get rid of can attach themselves to that small material. So that's something to really consider. Vacuum sweepers are the best on porous pavement. So if you have that, don't use water for dust suppression for vacuum sweepers. Regenerative air sweeper technology has generally been shown to be best for city sweeping. And if you really need to make an impact, think about tandem sweeping. Roger talked about that a little. At least one study showed that up to 500 pounds per curb mile was picked up by an air sweeper following right behind a broom sweeper. Think about that. Those are all going to be small micron particles. Okay, so how can you get more bang for your buck out of your sweeper program? For one, they can do some other duty. Many cities have a pickup truck or 2 or 3 or 5 that, depending on the city size, they have somebody in them. They drive all the streets every 6 months or every 3 months or every month to see if there are any signs down or limbs have fallen down or potholes. You can put a system on a sweeper, which is going there anyway, and outfit your driver with some kind of a keypad system. The keypad, when they see a sign down, well, maybe that's number 3. He pushes the 3, it automatically sends a notice. It has a GPS stamp on it. And so that goes to department that is in charge of down signs. Maybe he sees low-hanging branches. Well, that goes to the next department. And maybe a pothole pushes 9, that goes to another department, and it's all automatic. And with AI, I think that will may become all automatic with a camera system that just detects those kinds of things. I encourage you to use graphics on the side of your sweeper. A lot of times it's good to involve the kids. That's really is a way to advertise what you're doing throughout the community. Have graphics programs, maybe some for kids, some for adults. Take their graphics, put them on the side of your sweeper, or advertise the important things that they need to know about what that sweeper is doing. You can incorporate a QR code on the side. They can point their camera at it and go to wherever you want them to go on the internet. Sweeper naming is something that is really catching on as well. Lots of communities now have named their sweepers, and they put a contest out that involves the community, and at the same time you can talk to them about why that sweeper is being put there, and talk about the health and safety benefits that the sweepers provide. And you'll find that people will be proud that the city is keeping them healthy, safe, and that they have cleaner water than they would. So there's some ways to educate your residents about the pollution removal value that sweeping has. Touch a truck events with handouts and web info locations. Use social media and any other method you can think of to talk about the value of that this system has of street sweeping. I encourage you to develop grade-specific education and share that with other cities when you do it, other venues, because when you do that education in schools, and I'm thinking, primarily, say, 5th, 6th grade, to get it started at that time and teach them about what's going on when pollutants run downstream and what's happening there to the water. It'll really hold, and they'll go and hold their parents' feet to the fire and get them to understand just what's happening out there. Now, let's talk about the problem when you have not required that people move their cars. So let's say there's just one car. Well, that's not one car, that's 3 cars, because the sweeper has to pull out a car length before, go around the vehicle. It can't get pulled back in until another car length past that vehicle. And so you've lost 3 car lengths with just one vehicle parked there. And usually when it's not required that these vehicles get removed, unfortunately, there can be multiple vehicles, and sometimes it's not even worth sweeping that entire block. And a lot of times it's the same cars that are sitting there week after week, sweep after sweep. You'll have not only does it get unsightly, but with food and waste and so forth getting underneath these cars, it can be a rodent attraction problem and more. So you really need to educate people about that problem. And remember that the only way that you could remove pavement-based pollution at the best possible manner is to get vehicles out of the way of the sweepers. And let's talk about how astonishingly inexpensive this is. And I quote Dr. Sansalon here, and I'm going to read this because I think it really needs to be brought home. With conventional BMPs, particulate matter removal costs dollars per pound, anywhere from $4 to $41. For street sweeping, the cost for removing a pound of particulate matter was 10 cents. That's really the only thing people need to know, was what he said. But I disagree with that. I think they also need to know that we're removing things like phosphorus and nitrogen at a much lower cost per pound than any other method that's out there. So let's talk about technology now. I'm very proud of the education we've done at World Sweeper and the many stories that we come out with in our monthly newsletter, which is free. I'll show you at the end here how you can sign up for that. If you're not getting it, you should be. We've had a monthly newsletter for 18 years. So here's how we can take the sting out of your residents having to remove their vehicles. With the internet now, we can develop apps that are game changers for these programs. You want an app that works on phones, it works on computers, it works on tablets. It is connected to your GIS system or whatever you have that can come up with all the residents in your city. And they log on, and they, in these apps, if they're well designed, they can decide what they want to know about the sweeping program, because now they don't have to move their car for 4 hours. They have to move it to get out of the way of the sweeper. So they're a series of pull down menus, for example, and you could say, okay, I want to know, first off, when I want to notice when sweeping is going to occur. Now, I also want to notice, so I know what day it is. Let's say it comes to be the day before or 2 days before. Now, I also want to know when the sweeper is, let's say a mile away from me, from my residence. So that could be a pull down, or 2 miles, or whatever they'd like. Then we also want another notice for when the sweeper's gone by. So someone, and there are many more, they calculated that up to 30% more people during the pandemic, and in some parts now since the pandemic, are working from home that weren't before. So that allows these people, or stay-at-home parents or residents, they say, oh, the sweeper's coming. I knew it was coming sometime today. Now it's a mile away. Let me jump in my car, bundle up the kids. Let's go shopping. Or even you can just drive around the block and wait till the sweeper goes by. You get the notice on your phone, so you have proof that you knew the sweeper went by. And if there are any questions, and you go back and park, and you don't have to move for 4 hours. That makes the environmental value of street sweeping an enormously easier sell to your residents. And let's, while we're at it, streamline the process of ticketing the people that just won't move their vehicles. Now many of the cities are using, in fact, most all that move vehicles are using what are commonly called meter maids to go out. So you have to redeploy a whole section of people to go out and do tickets. I hear on social media all the time, I read and hear the complaints of people that the sweeper had gone by and they moved their car back, but they still got a ticket. Or the sweeper didn't come by ever, but they had parked there and they got a ticket. Even though, in at least one case that I recently came in, the city had announced that the sweeper wouldn't be running, but they still let their parking control people go out and give tickets to the sweepers. Now, talk about getting an uproar negative about sweeping. That's the way to do it. So what we can do now is put cameras on these sweepers. I talked about that a little bit in terms of the other things, AI, and combined with cameras, we believe will be able to notify your different departments of stop signs down and emerging potholes and that sort of thing. But for sure, right now, today, they can send a ticket. They can be ticketed, any vehicle that's in the way of the sweeper. The camera on the sweeper takes a picture of it. There's no doubt that they were in the way of the sweeper because the camera's on the sweeper. And that can then send a ticket to these folks. This kind of a system cuts the cost in doing the ticketing part, and it allows us, the residents to repark after the sweeper has gone by. And as Roger mentioned, tickets can pay for a significant portion of your sweeping program, allowing you to do even better quality, better job of reducing stormwater runoff pollution, as well as now trash amendments are being added in California and probably other places where we're realizing we need to get the large trash off the streets as well. So all of that gets affected. So when you do have a vehicle removal program, here's how to have a BMP outcome with what you design. Make sure you have a good method to show how people are going to be reminded about when they need to move their vehicles. How they've got to have a way for the city to notify these folks if changes have occurred at the last minute, and whether the sweeper broke down or it's pouring down rain or it's freezing or it's snowing or whatever, so they don't have to move their vehicles. And make sure they have a way to easily find out the sweeper has gone by so they can move their car back to the curb. And they want a way to ensure that they won't get a ticket if they move the car back after the sweeper went by, but before the no parking expired. So when you implement your sweeping program, vehicle removal pushback is minimized through education. So really take that as a leading tack to make that happen for you. You need a real-time notification system for when the sweeper is going to be coming, as well as any schedule changes. You need to have a vehicle removal system, which we can do now with technology that allows for immediate reparking. Coordinate your ticket writers with sweeper cameras and use the app, and you don't have to have a 4-hour window that people have to move their vehicles for sweeping. And as we have already talked, work to enact regulations in your state so that you can get credits for this pollutant removal. It's happening. Everybody wants to get rid of it. The EPA is on board with that fact as well. So go out and do what you need to do to get pollution removal credits that are aligned with your MS4 and or TMDL compliance. And the way to have courage of your convictions is to have data and this educational information that street sweeping is the first line of defense for pavement-based removal. So use that as your watchword. That's what gives you the courage to go forward and do things right. Now, Roger spoke a little bit about the upcoming microplastic study, Clean Streets, Clean Seas, Innovating Public Works to Intercept Microplastics in Urban Runoff. Microplastics are an enormous and emerging problem with waterways. I'm in the Pacific Northwest, and we're seeing a lot of that impacts to our salmon and other fisheries, including tire particles. And by the way, tire particles are considered to be a microplastic in this sense. Anything under 5 millimeters is essentially considered to be a microplastic. Sea Grant provided a $1.3 million grant for the city of Santa Barbara, who is running this, very capable PhD there, Jill Murray, will be at the head of that. And as it says here, the study will develop BMPs for the upstream control of this really fast escalating threat to marine ecosystems, which is microplastic. And we'll be trying to have an optimization study that we can learn if microplastic pickup rates can be improved and how it can be improved via sweeping, whether it's sweeper speeds or technologies, frequencies, and that's information that we really look forward to helping provide. As you can see here, there are a lot of agencies involved with this. I'm not going to read through them for you. Use your own eyes, and you can see that there are a lot of agencies interested in this topic, and it's moving very fast. We'll be developing BMPs for microplastic removal as well as tire particles. And by the way, tire particles have thousands, if not just hundreds, of different types of materials that are in them that are considered to be proprietary. They don't want to tell us what they are. And they're next time that you need a set of tires, think about what happened to those tires. What happened to the tread? Where could it be? Gravity works. Here's the sections that Roger and I will be working with in this microplastic study. We will consult with them on how to design the best possible vehicle removal app, what the BMPs should be with that. We will be implementing outreach to people like yourselves that are watching this, public works community, on the use of the various sweeper types and technologies, and what are the BMPs that you can achieve through your use of your street sweeper. What are the things you need to do to get those? We'll develop them, we'll document them. And we will be engaging with the street sweeping industry, which is to say the manufacturing community as well, so that we can educate them on what we're finding out are the BMPs for microplastics removal. One thing that concerns me and has long concerned me is this use of water for dust suppression, which is very standard in the industry. Yes, there are some sweepers that are considered to not have to have water in the long run. That is not actually true. They'll work for a while without water for dust suppression, and then that doesn't seem to remain the same. I did a research survey one time to try to find a dealer anywhere that would say that you don't need a dust suppression on your sweeper, and because their manufacturer sold dust-free sweepers or water-free sweepers, and none of the dealers would tell me leave off that system. We'll be talking about the sweeper testing methodology. We'll develop the best simulant for street dirt and whatever else we can think of, and then watch at World Sweeper and elsewhere. We'll be presenting the study findings so that users of street sweepers around the United States can have the best possible opportunity to maximize their sweeping programs. And I stand ready, and I know Roger does too, to answer any of your questions of people who are watching this, and guide you in the best possible directions as we've learned they are. And finally, for the last 18 years, we've had a monthly free e-newsletter at worldsweeper.com. I moved from American Sweeper, which was the first magazine of the sweeping industry in the early 90s. And we have moved that 18 years ago to worldsweeper.com. I've traveled to over 20 countries and taught sweeping and learned about sweeping, taught about best practices and so forth. Many of those are covered at the World Sweeper website. We have thousands of articles on many topics to do with sweepers, and to see the largest collection of information about street sweeping itself, you can see the email address there. I hope that if you do not get our newsletter, you'll sign up using the URL that you see there. So that's it for me. We counted this up, and it's actually scary. I know you see our beards are both white, and we've earned that whiteness because we have a combined 93 years of experience with street sweeping. And so if you need help and are wondering about any aspect of the sweeping industry, don't hesitate to contact either one of us.
All right. Well, thank you, guys. I know Roger's already been answering a few of the questions, but maybe we can circle back and address some of these. Roger, I know you've been looking at these questions. Do you want to throw any of these out there on the table? I think you're muted there, Roger.
I always forget to unmute. One gentleman asked me about wet streets and how that's a concern in sweeping, and it is, and it's a challenge. That's why you really have to have flexibility in your program, which we're not seeing, and the ability to contact your public and let them know, hey, something's changed, whatever. But what we did find in 1994 was extremely important, and I did respond and tell them that. The study, remember, we were going to go out the day before, sample, stay swept, The day after that, we sample again. Before, after, compare it. How do we do on the street dirt? Well, on 2 of the 6 times, it's Portland, Oregon. It was like, throughout the winter too, it rained. And on that second day, there's no way I'm going to send a street sweeper out and sweep in the rain. And I think most people know that that's kind of stupid, not to sweep in the rain. It's don't sweep in the rain. So, but then it came at this point where, should we go do that after? And thank God I decided to, because on both of those occasions, we documented the fact that the amount of material on the street after that rain was more than before the street. That's called wet weather wash on. It's an integral part of SimPTM. Without that, you can't simulate nothing anyway, anyhow. If I hadn't done that work, we would have never known about it. We've documented it a lot more. So there's the answer to the question. Don't sweep in the rain. Recognize, though, if you have some flexibility in your program, you might want to get there after it rains, because there's going to be more street dirt on the street, most likely, if it's at least a ½ an inch per hour intensity. That seemed to be the trigger. So that's one question I answered. I didn't see any of the other ones.
There's another one, Roger, that says, do you have any data regarding removal of phosphorus, which I think we saw, but zinc. I don't think you mentioned zinc, and that's in tires, as you were talking about.
Yes, in fact, the work we did in this California, in Burbank and Glendale, you can contact Chris Minton at Larry Walker and Associates. We have data we collected. We focused on metals. It was related to the TMDL, the LA basin, and we showed very significant removal of metals as a direct, and we're talking about street dirt sampling before and after, and we've documented that we can get significant. And those numbers that I showed you in San Diego we're in the same order of magnitude is what, we found that, although we didn't sample runoff, so.
All right. Okay, Mel, I believe with Caltrans has a question. What are your thoughts about 6-ppd? Are you familiar with that? I'm not.
No, I'm not familiar with what 6-ppd means.
Mel, go ahead and unmute if you want.
Whoever asked it.
I don't know if Mel's still on. But Mel, if you're on and you want to field that question yourself, she has another one here recently.
Yes,
go ahead, Mel.
6-ppd is just another tire constituent. I know that Caltrans is concerned, or sorry, California is concerned because it can kill salmon. But I mean, from my point of view, I was just wondering if you had any thoughts on that.
Well, we haven't done anything in that regard. In fact, that's why we're so excited about this microplastic product. Tire particles is a huge microplastic. And part of the work we're going to do is we're going to conduct some pickup performance tests on street sweepers. We're going to throw microplastics into the mix, into the simulant we put together, and we're going to find out whether the street sweeper can be effective in picking it up. We're also looking at collecting data in the city of Santa Barbara, like we've done before, before and after sweeping and that sort of thing, and see whether we can translate what we learned in the, sort of like in the performance test in that regard. So we don't know anything about it, but I have to tell you, the odds are sweeping is going to rock, because remember, what's important in picking up particle materials is its mass, its weight, it's heavy. It's 2.6 times heavier than water. Microplastics, they're not heavy. They're very light. So I don't think it's going to be an issue, but until we do the work, we can't say for sure how effective they're going to be, because the size is an issue. These are small things, but so is 63 micron particles.
All right.
On this one too, John. I just checked the ustires.org, which is a U.S. tire manufacturer's website. They say that there's not a viable alternative to 6-ppd, but I'd sure hold their feet to the fire to find one, because you're right. In the Pacific Northwest, salmon degradation is wildly fast, and we need to do whatever can be done. There are a lot of other particles, components that are in tires that the manufacturing community does not want to divulge, and they're calling them proprietary. But we need to find out what those are. I think we learned a lesson about that with fracking, when the oil companies were putting all kind of chemicals in the water that they were shooting back down into the ground, and there were a lot of repercussions because we didn't know what those were. So I'm not sure how we can get to the source and get those stopped, but the next alternative is to get them, pull them out of the water, out of the system before they can get into the waterways.
Yeah, that's right. Well, Ranger and Roger, this has been great, fascinating. In fact, I want to learn more. I'm definitely going to go check out your websites and at worldsweeper.com. Definitely, I saw some good articles. I was looking at it even as you were speaking. So thank you for being a part of this. And we will have this recording up online on the Stormwater Awareness Week workshop. So if you know of somebody who wants to see it, or you want to review it yourself to see some of those slides that they showed, they will be available in about 24 hours. So we're out of time, unfortunately, but thank you for presenting, Ranger and Roger. Thank you to you all who attended, and we hope you can attend another Stormwater Awareness Week workshop.
All right.
All right. Thanks.
Later.